So we got home from a trip and our furnace, this Tempstar furnace, had stopped working. Welcome to Tomahawk DIY, everyone. I'm Mike. Let's take a look in here. First we pop off the panel. This is where the flames burn from. I'm going to turn this back on. It's going to get a little noisy. Alright, you see the furnace trying to heat up. Now what's going to happen, the blower motor down here is not actually going to turn on. And so with the furnace blowing flames, it's heating up. Sensor's right back there. And it's going to trigger safety and say, hey, it's getting too hot inside of here, so turn off. By this point, the blower fan down here should be kicked on, blowing the air to help circulate the heat through the house, and it's not turning on. Alright, it might take about a minute or so, but then we're going to have this thing, it's going to turn off the gas, say it's not safe. Alright, there we go. You see it kicked off? That's because the safety triggered and said, hey, this isn't working. It's getting too hot in there. The air's not moving. There's a problem. So the control board here for the regulator cut off the gas. Let me orient you to some of the components in here and tell you how I was able to keep the furnace heating the house until my parts arrived from Amazon. Alright, first let me point out a few things. This is a disconnect. That turns the power off to the whole furnace. So if it's on, you just hear it fired up, the fan started blowing. So we're obviously keeping it off for safety and things like that. In this upper half of this Tempstar furnace, we've got the gas manifold here. So the natural gas comes in through here, flames up. We'll see that in a little bit. This is the gas regulator. This is the control board that controls the regulator and the flow of gas. So that's got a lot of safety features. I actually have a video where I replaced this recently. I think in replacing that, I didn't actually find the culprit. Got the furnace working, but then we fried a different control board a few months later. So hopefully today's efforts will keep this thing running smoothly. This is an exhaust fan. So this fan takes the fumes from the combustion of the natural gas, sends it up through the duct and out the house. So that's what's going on up here. Now let's come take a look down below. So let me give a little safety warning. If you work on furnace, you're at your own risk. You gotta be smart and understand what you're doing and don't do things that you're not comfortable with. So I'm just demonstrating what I've done and can't take responsibility for any actions you might take. Alright, because I'm in here working on the blower motor, I've actually had to bypass the safety switch, so it's taped down right here. And that's there for obvious safety reasons. We've got the motor on this side, we've got the fan right here, and that's what actually blows the air through the house. And then I've got a circuit board, a transformer, and a capacitor. I believe my transformer might be the problem, but it's fried part of the circuit board. And I'm going to replace the capacitor while we're at it, just because it's low-cost part, and I don't want to deal with furnace anymore. So in this process, we're aiming to replace anything that could be causing us problems. Before I begin or repair, especially with wiring or lots of details, I like to take a bunch of photos. Just trying to get it from all different angles to kind of see around these many wires and understand what's plugged in where, just in case I run into problems. It can be a handy reference. Now I kept my furnace running until the parts arrived by bypassing the fan control board and powering on the fan 24/7. Not energy efficient, but it kept us warm for a couple of days. To the control board here, you can see this orange wire that I've tied in with these blue wires. This was a temporary solution. I got a great suggestion from the YouTube channel Word of Advice TV. That's a great spot to go and check out some HVAC tips. Highly recommend it. I'll include a link down in the video description to help you find that channel. But he pointed out that sometimes if you have a problem like we had, the fan wouldn't blow, and so the furnace wouldn't run. It kept getting cold in the house because of that. The problem was with the circuit board, it appears, and so we just bypassed that part of the circuit board and plugged the fan in so it runs continuously, but it kept the air moving, and then it allowed the furnace to kick on and fire up. So now that we're going to replace this, we got to put things back, get them undone. I'll take the orange wire out, and then need to this blue Found that the blue is the incoming power from tracing it through where it went, and also by taking a look at the diagram, the wiring diagram. So this is basically a map of all the wiring, and that helped me identify. Let's get our incoming power wire back together, and maybe by the time we're done, we'll have this actually replaced entirely. At the risk of making a mess, I'm going to cut this zip tie so I can work on these wires a little bit better today, and then we'll zip tie it all back up. In order to make this temporary connection that we had going, I've got to put a new insulated disconnect onto this blower motor power wire. So that's pretty straightforward. Just cut off the part that's been damaged. I'm going to strip the end. Just make sure that depth is right. Okay, if we got that, it's going to stay in. All right, so let's work on fixing this control board. I'm turning the power off here. Using my multimeter, I did all sorts of testing down here to trace wires and figure out where wiring was going and where it wasn't going. Word of Advice TV really walks you through everything you need to know with your multimeter to check power coming in to the board, going through the transformer, coming in one side at 120 volts on this furnace, coming out at 24 volts, coming out to the blower fan, which is where I discovered that this orange wire that did not have 120 volts coming out of it or coming from the control board to it. So there's something that seems to be fried on the control board. Tested the capacitor. This transformer was coming in at 28 volts instead of 24 volts. So that led me to decide to replace this, wondering if the higher voltage coming out of here, if this is starting to fail and it actually fried something on the circuit board. Let me show you what I did to keep this thing running for a time until we could get the parts that we're going to put in today. All right, so let's go get to work replacing parts. I'm going to start with the capacitor here. Remember, I've got power turned off to this entire unit. I can also turn power off at the circuit breaker as an added measure of safety. Now, a capacitor stores energy, and this thing basically gives a good kick to get the blower motor up and running. So we got to be careful of safety here, because this has a stored charge in it, and it can really hurt, possibly even cause injury. But that should discharge any charge that's been built up in this. All right, Word of Advice TV channel has a great video that explains all about capacitors. In a nutshell, this 10 UF, that's 10 microfarads, and this is a 370 volt capacitor. So I bought another one that's also 10 microfarads, 370 volts. It's going to be shaped a little bit differently, but it'll serve the same function. Here's that new capacitor. So let's work on getting this put back in place. Here's what I've decided to do. I've widened out the bracket here. Before I drill through here, I'm going to reach back behind, just check, make sure there's no wires, there's nothing back here, and it's all clear. I'll put the screw back in on this side and drill a new screw hole on the other side. Don't forget to reconnect the ground. This is grounding the circuit board electrically. With that back in place, you're now take these clips. It doesn't matter, one on each half of the capacitor. It doesn't matter which half it goes on, which wire goes on to which half. In this case, there are some capacitors where that does make a difference. To replace the transformer, it looks like I've got to get this whole mounting panel off. So, okay, now with this loosened, I'm going to watch my wires, make sure I'm not pulling anything unnecessarily. Now I can get a better view of this transformer. It's held on with, it looks like, with these clamps right here. This thing's got some pretty good weight to it. Alright, so this is a point where I'm going to take a couple more photos just to remind myself what I'm removing in case I need to undo it. Okay, let's unplug all those. Okay, with that, got the transformer off. Now here's the new transformer. We're going to set this new transformer aside. We'll get the circuit board taken care of first. Okay, I'm going to leave the wires on the circuit board while I pop it off. This one, there's some little clamps here. Should be able to. Looks like it's a little easier to give them a pinch on the back side first. And then they come off quite easy. Alright, let's see what's inside the box of this Honeywell Universal Circuit Board. We've got some wiring harnesses. That should make things easier. Screws to put it on, instruction manual, and the board itself. Let's get this new board mounted and then we'll start wiring it up. Alright, the circuit board mounted, now we can start working on the wires. Alright, the first one we're going to do is this ground. So it's really important that you make sure you're putting these in the right spot. So it's easiest to do it one at a time. So this guy lands on here, it's going to get connected back down there. Alright, as we start wiring, just got the ground put on. This manual, here's a table, it's going to be our friend. We're going from an ST1920, the C version, but this column is just for any ST1920. And then over here is the ST1920U for Universal. So for our power, I'm going to find, I know this is my incoming power, it's on S. There's S1, 2, and S3. So if I come look down here, here's S1 through S3, and then over here on 19U it's L1. So that's basically what we got to do here, is move these one at a time. Okay, so pull this one back, it goes over here on L1. That's my incoming power. Next one, I'm going to do my neutrals. On this board, it looks like I've got 3 neutral wires connected. I'll do my best to try and keep these kind of orderly. Put it here. Let's get my next 2 neutrals. On here, I've got a D1, or DI rather. And looking at my cross-reference sheet, DI goes to IND. So that's right here. Next, here's my cool. So this is going to be when the air conditioner is running. It's going to fire up the fan, the blower back here. And that's going to connect up here on cool. And then right here I've got one on heat. This one comes up to heat. There isn't a whole lot of indication around that one. And it fits onto this clip. Let's see, what's this blue one? The blue one says unused motor leads. And unused motor leads goes to unused. So where's unused? Let's get one on, get the other on. There's a 5 amp fuse here. There's a 5 amp fuse right there. Now here are my thermostat wires. We're going to take thermostat wires one at a time. C and C and Y on this first one. So I've got C, I've got C and Y. Let's plug back in. And we've got G on green, I've got this blue on Y, I've got a white on W, and an R on red. So we're gonna get all these pulled out. And where's that green? All right, now the last thing we gotta wire up is transformer. Remember this guy? Make your life easy and get your delay set before you wire it up. Unfortunately, I neglected to do that. A bit of tape, and it's kind of tricky to get a hold of. These tweezers are helping though. But you need to adjust, well, you need to check the table and see what kind of adjustments are recommended for the various delays on the system. This tells the control board how many seconds to wait to do certain things. Alright, we got that off. On my old circuit board, ST9120C4057, and I come find that on my table here. See, there's the 4057. Come over. It's got the legacy timing, so this tells me what it used to be, 30, 140, 30, 30. And over here, heat on. Number 1 should be off. So let's see. So there's off. So remember our transformer, remember we checked. Need to make sure it's got all the same ratings, output of 24 volts on the new one as well as the old one, input of 120, etc. So this new one can take 120, 208, or 240 volts. So the red and orange, it tells me, are the 208 and 240. So I put a wire nut on the end of these because you don't want those wires touching anything and shorting stuff out. I can probably bundle them up and tape them together just so they're not dangling once we're done. I'm gonna get this mounted on here. All right, let's finish getting this, get the second screw on this transformer. Now we need to get things wired up, which means I need to get some clips onto the end of all these wires. Make sure it's holding good. Let's get our transformer wired up now that it's installed. Okay, the blue transformer wire was on X on the old circuit board, so we're gonna put it on X on the new one. Okay, with all my wires on, let's get this whole mounting board hung back in place. And then it'll be the moment of truth. Well, I've just finished checking all the wires to make sure that they're fully connected. I did find one surprising thing. My transformer is labeled that white is 120 volts and black is the neutral. So that was a little bit surprising there. I checked the paperwork that came with the transformer and it said the same thing, black being neutral and white being the 120 volt line. Both places were kind of backwards of what I expected. So everything seems to be wired up properly. It's the moment of truth. We're gonna try turning this thing on, see if it works. All right, the thermostat had been turned down low while I was working on this. Burner just fired. You can see it there if I turn the light on. I do like that this new circuit board has a green indicator light. You see it there? Right there? My old one was sold, it didn't have that. And so the indicator light can give some clues as to what's happening. Alright, the blower turned on. running. There's a whole checkout procedure to verify that everything's working as it should after getting that board installed. So this will take a little bit of time to go through. It walks through each of the steps that are needed. Please leave a comment, let things know how it works for you. Be sure to check out Word of Advice TV, an HVAC channel that really had a lot of detail on how to troubleshoot and look into what's going wrong with your furnace.